Okay, we're moving on to section 10.4, angles and parallel lines. This on page 235. Parallel lines, I think probably when you were in primary school you would have known parallel lines are two lines that will never meet. They're always the same distance apart. Okay, and train tracks are a good example of that. They're the same distance apart all the time because the train is the same distance apart, so the wheels on the train. So parallel lines are two lines that are the same distance apart at every single point. Okay, so in lines L and M are parallel. They're denoted, if you ever see two little arrows on lines, that means they're parallel. So in a diagram, they mightn't tell you it's parallel, but they might do those two little lines. Or they might also use this symbol. I'll just zoom in. L and two straight lines parallel to M. Okay, so that's the way we know two things are parallel. They'll either tell us in the diagram with arrows, or they might tell us in the question with that, or they might say it in words. Now that brings up, when we have two parallel lines and we draw another line through them, it gives us three rules which we're going to look at today. Okay, and then we're going to attempt to answer some questions based on them. And it actually turns out to be, it's hard sometimes to identify which one you're looking at, but actually I'll do a summary at the end. We'll talk about how easy this actually is. Okay, right, I want you to take down these notes. So the first one is corresponding angles. So a little subheading, corresponding angles. And what I've drawn here, I've drawn two diagrams, and I'll do two for each of these. I've drawn two parallel lines, and look at the arrows to show they're parallel lines. And I've drawn a line through them. Two parallel lines and a line through them. Now when I draw a line through them, it creates angles. And corresponding angles are sort of, if you can picture an F shape. So I'll just draw an F shape here. You see that F shape? Corresponding angles are the angles under here. This angle and this angle are the same. And sometimes they're known as F angles, but corresponding angles. So I just want to take on down on there. Corresponding angles are equal. Similarly, if a backwards F, this angle and this angle are equal. Similarly, an upside down F, this angle and this angle are equal. And a backwards and upside down F, this angle and this angle are equal. And I'll show you that in a summary at the end. And hopefully that will bring it all together. But when you look, and if you see an F shape, you can say that that angle and that angle are the same. That angle and that angle, remember backwards one. That angle and that angle, that angle and that angle. But again, just take down this for the time being, and when we go on to do a couple of examples, you'll be able to hopefully get this a bit more. Okay, the second one I want to take down. Again, let's look, again, if we drew the F shape, I could say that that angle and that angle, but I'll just show you by doing a different F. Let's say an upside down F. And back to front. So I can now say that this angle and this angle are the same. Again, similarly, I could have said that this angle and this angle are the same. This angle and this angle and this angle and this angle. But I'm just showing you a couple of different ones. And they're called corresponding angles. Alternate angles are also equal. Okay, none of these contradict each other. They all complement each other. They're all different ways of showing different things. But an alternate angle you're looking for, I'll just put up here an F shape you're looking for with that one. And in this one you're looking for a Z shape. So in this I'll just do a sort of a weak red line. When you see that Z shape, the angles within the Z, this angle and this angle are equal. Okay, so alternate angles are also equal. And again, I've drawn two more parallel lines, and I've drawn lines, and we're just doing them at a different orientation. If I look for a different Z shape, and this one isn't, so obviously you can see that Z shape there. But if you look at the other side of it, that is sort of a stretched out Z shape. that angle and that angle are equal. And the same way this angle and this angle are equal. So, and the same way this angle and this angle are equal. So alternate, you're looking for this Z shape, and its alternate angles are equal as well. So if you could take down those as notes, and we'll move on to the last little bit of notes for this. Okay, we're on to interior angles. Interior angles are looking at sort of a C shape. So we can see it here. There's a C shape. Now these are slightly different than the others. This one probably you'll use the least. This angle and this angle inside the C, they're not equal. We'll call this one A and this one B. A plus B equals 180 degrees. We'll do an upside down sort of C, facing downwards. We'll call this C, we'll call this D. C plus D equals 180. So they're not equal interior angles. Just take down interior angles add up to 180 degrees. Okay, and there's one last little thing actually I want you to take down in terms of notes, and then we'll do an example, and then I'll let you get on with some questions. Our last thing, I just want us to look at everything as a whole and link them all together to show you that none of them contradict each other. So if I draw a line, and let's do it horizontal, just to a line, and we'll draw another line here. And we'll say those two lines are parallel. Okay, they've got those arrows. Those two lines are straight and they're parallel. If I draw again a line through them, I've created how many angles? I've created 1, 2, 3, 4, 5, 6, 7, 8. I've created 8 angles. However, there will only ever be 2 types of angle. You can see there's an acute angle and an acute angle, and then there's an obtuse angle, obtuse angle, obtuse angle, obtuse angle. And I'm just going to mark the acute angles with a red. So say if I said this was 30 degrees, why would this one also be 30 degrees? Because remember the last day we said that opposite angles are equal, so that has to be equal. If this is 30 degrees, why is this one 30 degrees? Because can you see that upside down F? This angle is corresponding to this angle. But also this angle is alternate. Can you see that Z shape? This is alternate to this. This is an upside down or backwards F. So this one's equal to this, and this is also opposite. So they all complement each other. And if I do the obtuse angles in a blue, why are those two angles equal? Because they're opposite. They're vertically opposite. We've already come. If we look at this F shape, this here will also be blue. And if we look at this upside down F shape or this Z shape, this will be blue and opposite. So you can see these are going to be the same because they're opposite, but also this is going to be the same because it's an upside down back to front F. This is going to be the same because it's that Z shape. So all of these rules complement each other. And the final rule was the interior angles. What can I say about the red and the blue? Is that a straight line? Yes, it is. So what should it add up to? 180 degrees. So the red and the blue add up to 180 degrees. So the red and the blue add up to 180 degrees. The red and the blue add up to 180 degrees. So interior angles, that C shape, add up to 180. Okay. So this will just tie it all together. You should take down the last ones, but just remember, when you draw 2 parallel lines and you draw a line through them, you only actually create 2 different angles. The acute ones are all the same and the obtuse ones are all the same. Okay, so you might want to take that down. Acute angles are all equal and obtuse angles are all equal. So there's only 2 types of angle in this particular one. I'll just do the red dot there and the blue dot, and then obviously the interior ones, they add up to 180. Okay, so I'm just going to do one example and then we'll get you to practice some. Okay, the example in the book asks us to do this question and asks us to find out A, B, C, D. Now, I told you in this last example, or the last thing I got to take down, that's only going to be ever two types of angles. So 115 and one other one. But I'll just go through the process. I'll follow the way that they do it in terms of they want you to find A then first. What is A? A is opposite 115. So angle A is equal to 115. And they might ask you for a reason. You could say it's opposite, vertically opposite angle. That's what they say. So if A is 115, B, because we'll do it in the order they want, angle B is also 115 degrees. Can you see there's that backwards F shape, and these two are the same because it's a corresponding. Or another reason you could have said it's corresponding to A, or you could have said, look, B is that Z shape to 115, so it's also alternate to 115. So there's two reasons you could have given there. You don't need to give two, but just all of these reasons, like I said, will complement each other. One's not going to contradict another one. C again, you could either say it's vertically opposite to B, or you could say it's corresponding. Sorry, it's 115 again. Corresponding to C is corresponding to 115, or you could say it's vertically opposite B. And the final one, angle D. Remember, there's only two types of angles, 115 and one other one. And look, if you block this off, 115 and D are a straight line, so it should add up to 180. So 180 minus 115 is 65 degrees, and it's because it's a straight line. Now I could have told you straight away, if that's 115, the other angle is going to be 65. So all the obtuse angles are 115, and all the acute angles are 65. So 65, 65, 65, 65. Very simple once you get the hang of this. And there'll only ever be two types of angles that you get in this sort of scenario. But sometimes they would ask for a reason. So now, vertically opposite, corresponding is when you're looking at those F shapes, and alternate is when you're looking at those Z shapes. Okay, so I'm going to give you some questions. Try them and please ask if you're unsure.